This is problem number 53 in Chapter 10, Section 3, solving a system using matrices. I have a system of 4 variables. I have my 4 equations. I write the augmented matrix, and now I start working on my goal of REF, row echelon form. I need this upper left element to be a 1, which it is. I need the element below that to be a 0, which it is. And I need the element below that to be a 0. Well, it's not. So this is the row that I need to fix. I need to get this first element here in row 3 to be a 0. To do that, I just subtract row 1 minus row 3, and I get this result, 0, 2, negative 2, 0, negative 8. But all of those elements are divisible by 2, so I'm going to divide them by 2 and simplify. And it's this row, 0, 1, negative 1, 0, negative 4, that I am going to replace into row 3. So I'm going to get rid of this row and write 0, 1, negative 1, 0, negative 4, which I have done. Now you might stop here for a minute and say, but rows 2 and 3 are exactly the same thing. It's true, and we'll deal with that in a little bit. I kind of want to just keep moving on with my row echelon form, and we'll talk about what's going to happen here in just a minute. But in row echelon form, I realize that row 4, I need a 0 here as well. So I'm going to take 2 times row 1, subtract it from row 4, and replace row 4. So I go ahead and I do that, and I get this result. Nothing simplifies, so just put that in for row 4. Now I'm looking at this, and I'm moving on with row echelon form, and my diagonal should be a 1, and then a 1, and then below this 1 needs to be a 0. It's not a 0. So to do that, I would subtract these two, row 2 minus row 3, and put that into row 3. And I notice that when I subtract, I get all zeros. And that's okay. Just go ahead and write that. So you'll see here, I have replaced row 3 with a row of zeros. So that equation just says 0, 0, 0, 0. There's nothing wrong with that. But I'm going to exchange rows 3 and row 4, because if I have a row of 0, I want it to be at the bottom of my matrix. I don't want it kind of sitting in the middle in row 2 or row 3. So I'm going to switch rows 3 and 4, and here I've done that. So now I have the zeros on the bottom row. What that means now is I'm only going to be able to solve for 3 of the variables, and the 4th variable will have to be, it can be anything I want, and so I'm going to give it its own letter. You'll see that in a moment. So now, instead of row echelon form, where I'd be looking at this square matrix, this 4 by 4, I'm not going to be able to get this to be a row echelon form, because this, in the bottom 4th row, I'll never get this element to be a 1. So instead, I realize I'm only going to be dealing with 3 variables, so I'm going to be looking at the 3 by 3 matrix. And I'm going to be concentrating on getting this 3 by 3 matrix to be in reduced row echelon form. That's the real goal here now, is I need it to be reduced row echelon form. So I need this element to be a 0, as well as these. I need all the elements that are not on the diagonal to be zeros. So to do that, I take row 3, add it to 4 times row 2, and that will be replacing row 2. So I will have a 0 right here. And when I do that, I have this result, placing that into row 2. Here I've got it. And you might be worried because you're looking at this 3 by 3 and saying, well, my diagonals aren't 1. That's okay. We want to get all the zeros below the diagonal and zeros above the diagonal. We will then, after we get all the zeros, work on getting the diagonals to be 1s. So I need to make sure that in that first row, this element that's the first row element, column 2, and the first row column number 3, both of those to be zeros. And to do that, since this one's already a 0, I only need to worry about getting rid of this 1. So if I do 4 times row 1 and subtract row 3, it will get rid of that element in the column 3. So I do that, and here it is, and I replace that into row 1. So we're going to go to the next page, where I'm going to put this into row 1, 40077. And so there it is, 40077. The other 3 rows are exactly what they were a moment ago. And now, again, I'm looking at that 3 by 3, and since the diagonals are all 4s, each row, I'm going to multiply this by 1/4, the whole row, row 1. And row 2, I'm going to do that same thing because I need to get this element right here to be a 1. And row 3, since it's also a 4, I'm going to multiply that row by 1/4 as well. I'm going to end up with a lot of fractions, but that's okay. And at this point, we've got our 3 by 3 in reduced row echelon form. So we're going to write these 3 equations that they represent. So I've got x plus 7/4 w equals 7/4. I've got y minus 3/4 w equals negative 7/4. And I've got z minus 3/4 w equals 9/4. So what is it that this row represents? Well, this row represents the fact that w equals, I don't know, it can equal anything we want. That's why this is called a dependent system, that w has infinite possibilities. And so what we do is we're going to solve each of these equations in terms of for x, y, and z, and it will be in terms of w. So when I solve x, I get this. When I solve for y, I get this, and solve for z. And what's left is w. And so I'm saying that w can be anything. There's infinite possibilities. So we use the letter t, which means wherever I see a w in these 3 equations, I need to replace it with t. And at this point, we have solved for each of the variables, x, y, z, and w, in terms of t. We write that as an ordered quadruplet, which looks like this. We've just taken each one of these answers and put them where here's x, here's y, here's z, and here's w. And this matches the answer that's in the book, so you can see that they did do it in the order x, y, z, and w.